Well, hello. If you are a distance learner, you've just finished your physical science force test. And force is a good way of leading us into our next idea, and that idea is pressure. And if you think about it, you can probably see how there's some similarities here. You think, hey, someone's applying a force on me or someone's exerting pressure on me. You can see how they're somewhat related. There are some differences, and I want you to kind of maybe think about what those differences might be before we get started today. There's a way of kind of thinking about pressure that is going to be well kind of illustrated in this lab here. So the thing that we've got to know here is our equation for pressure is that it's going to be force divided by area. Okay, and you should have this sheet in front of you, and you've got this available here. So we just finished the chapter on force, and now we're going to see what happens if this force is exerted over an area. Now, when we've worked with force, you should know that force is measured in newtons, and an area is measured in, the way we measure it in the metric system, is going to be in, we measure distances in meters, but we are going to square that. So it is newtons per meter squared. Now that ends up being kind of a mouthful, so we're going to actually call that after someone who dealt a lot with his experiments with pressure, and his name was Pascal. Okay, so if I have a force divided by an area, that is a newton per square meter, but 1 newton per square meter is the same as 1 Pascal of pressure. Okay, now there's other units you can measure pressure in, like if you're filling up your bicycle or car tire, you might measure that in pounds per square inch. Okay, you could also, in chemistry, you are going to perhaps measure in atmospheres of pressure. Here on Earth, we experience 1 atmosphere of barometric pressure. If you are a meteorologist, you might measure pressure in millimeters of mercury. Okay, so there's lots of different ways you can measure pressure. And today's activity is going to help us measure pressure. Now, notice that if I have pressure equals force divided by area, I can kind of get 3 ideas for one here. Okay, I can say that area then equals force divided by pressure. That will give me the area. All I'm doing is kind of reinverting those ideas. And if I want to get my force, actually let's roll down one here. If I want force, force is going to equal pressure times area. So I got 3 equations right here for the price one. They're all saying the same thing. It's just rearranged depending upon what you're looking for. So today in class here, what we're doing in class is we're going to do a lab which we're going to measure the pressure. So we're using a block today that has a mass of 320 grams. Okay. Now you have to switch grams into kilograms. So you should know how to do that by now. You're going to divide by 1,000. So that's what our mass is in kilograms. You should also know the answer to number 2. The acceleration due to gravity on Earth, kind of think about for a second. It should have been on your test today. That answer should be 9.8 meters per second squared. So if I want the weight of this block, okay, and this block looks like this, okay, it has a mass 320 grams. So what I'm going to do, if I want to figure out the weight, weight is mass times acceleration. Here's my mass, here's my acceleration. So if I multiply 0.320 times 9.8, I'm going to find out that that block has a weight of 3.1 newtons. Okay, so that is actually going to be a force. Remember, pressure is a force divided by an area. So we're going to measure the dimensions of this block. This block has different areas. I could have the large surface here. I could have the small surface here. I could have this medium-sized surface here. We're going to first focus on this large surface. this large surface has an area of 20 centimeters, or let's go straight to the punch here because we're going to deal with meters. It's 0.20 meters. Its width is that. You should be able to figure out the area from that. Now the pressure tells you what to do there. We're going to figure out the pressure. But then here, let's look at the smallest side of our brick. The smallest side is a little bit different. Okay, so on one of these, we're going to lay the brick flat like this. On another, we're going to lay the brick flat like this, or the block flat like this. We're going to see different amounts of pressure here. So the second time, we're going to have a length of that, but then this very smallest edge, 0.035 meters. And so then you can work through these. And we're going to determine the pressure of each. And then I want you to answer these types of questions that follow. Now, I gave you equations to solve these. Those were those 3 equations at the top. You should be familiar with trying to use those. Okay, and again, I'd recommend guessing. What is the problem giving you? What is the unknown? Figure out what you're looking for. Okay, so this is what I'd ask that you complete after you are done with your test today. Okay, so that's going to be the game plan. Okay, if you've got any questions, do not hesitate to send me a chat, and I'd be more than happy to help you out. Okay, we will talk to you later. This is due next class.